87% of AI agents in production right now are flying blind, and their developers have no idea why they're failing.
Wait, are you saying most teams can't even debug their own agents? So we're covering what makes agent observability different, these new primitives like runs and traces, and how to actually implement them?
By minute 4, you'll know exactly how to instrument your agents for real evaluation. Let's get into it.
Welcome to the AI Daily Podcast, today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into agent observability, powers agent evaluation.
Stick around to the end for today's headlines. Let's dive right in.
So let's get into the meat of this. The first thing to understand is that agent traces are fundamentally different from traditional application logs. We're not just recording events, we're capturing decision trees.
Can you give me a concrete example of what that looks like?
Sure. Let's say you have a code review agent. In traditional logging, you might see received PR, analyzed files, posted comment. But with agent tracing, you're capturing things like agent considered using syntax_check tool, but decided semantic_analysis was more appropriate because the PR description mentioned logic changes. You're seeing the reasoning.
Oh, so you're actually capturing the why behind each decision.
Exactly. And here's where it gets really interesting from an implementation perspective. Teams are finding they need to instrument at multiple levels. You've got your high-level trace that shows the overall task flow. Then you drill down into individual LLM calls where you can see the exact prompts, the token usage, even the probability distributions for different responses.
That sounds like a lot of overhead. What's the performance impact?
It's significant, I won't lie. We're seeing teams report 15 to 20% latency increases when they implement comprehensive tracing. But here's the trade-off. Without this visibility, you're flying blind. One team I talked to spent 3 weeks trying to debug why their agent was occasionally deleting important data. Turns out it was misinterpreting a tool description. With proper tracing, they would have caught that in hours.
How are teams actually storing and querying all this data? Because a single agent session could generate hundreds of megabytes of trace data.
Great question. The successful teams are being smart about data retention. They're using a tiered approach. Full fidelity traces for recent runs, then progressively summarizing older data. Some are even using LLMs to summarize their own trace data, which is pretty meta.
That's clever. What about the evaluation side? How does all this trace data actually help with evaluation?
This is where things get really powerful. Traditional evaluation might just check if the agent achieved the goal, but with traces, you can evaluate the journey. Did the agent use tools efficiently? Did it get stuck in loops? Did it consider the right options, even if it chose differently?
Can you walk me through a specific evaluation scenario?
Let's take a customer service agent. Traditional evaluation, did it resolve the ticket? Trace-powered evaluation, did it access the right knowledge base articles? How many clarifying questions did it ask? Did it escalate appropriately? You can even do things like replay traces with different prompts to see if you can improve the reasoning path.
But doesn't this create a new problem? Now you need to evaluate the evaluations. How do you know what constitutes good reasoning?
You've hit on one of the biggest challenges. Teams are developing rubrics for reasoning quality. Things like minimizing tool calls, avoiding circular logic, maintaining context across long conversations. Some are even using adversarial testing, deliberately trying to make agents fail to understand their boundaries.
This sounds like it requires a whole new skill set. We're not just writing code anymore. We're almost like AI psychologists.
That's not far off, and the tooling is evolving to match. We're seeing specialized platforms that can visualize reasoning chains, automatically detect anomalies in agent behavior, even suggest prompt improvements based on trace analysis.
What kind of metrics are teams actually tracking?
Beyond the obvious ones like task completion rate and latency, we're seeing metrics like reasoning efficiency, steps taken versus optimal path, tool utilization rates, context window usage, even confidence scores based on how certain the agent seemed in its decisions. One team tracks decision reversals, how often an agent changes its mind mid-task.
That's fascinating. It's like we're developing a whole new discipline around understanding and improving agent behavior.
Stick around, and our final act will give you the exact framework for implementing agent observability in your own systems, plus what to watch for as this space evolves. All right, let's talk about what you can actually do with all this information. If you're running agents in production or planning to, here's your playbook.
Yes, because I'm literally going back to my team after this and need to know where to start.
First thing, instrument early and instrument everything. The biggest mistake teams make is waiting until something goes wrong to add observability. Start with these basics. Capture every LLM call with full prompt and response, log every tool invocation with parameters and results, and track state changes throughout the agent's execution.
What about tooling? Should we build or buy?
For most teams, I'd recommend starting with existing platforms like Langsmith or Weights and Biases, then building custom instrumentation for your specific use cases. The key is choosing tools that can handle hierarchical traces. You need to see both the forest and the trees.
What about the evaluation side? How do we move beyond just did it work?
Start by defining what good looks like for your specific agents. Create rubrics that evaluate both outcomes and reasoning quality. For example, if you have a code generation agent, don't just check if the code works. Evaluate whether it considered security implications, wrote tests, and followed your team's patterns.
That makes sense. What about the human element? This seems like it requires different skills from traditional engineering.
Absolutely. You need people who can think about AI behavior patterns, not just code patterns. Some teams are creating new roles, an agent reliability engineer or AI behavior analyst. These folks spend their time analyzing traces, identifying patterns, and improving agent performance.
What are the biggest pitfalls teams should avoid?
3 big ones. First, over-instrumenting to the point where the observability overhead kills performance. Second, treating agent traces like traditional logs. You need different tools and mental models. Third, focusing only on failures. Some of the best insights come from analyzing successful runs to find optimization opportunities.
What should teams be preparing for as this space evolves?
We're going to see standardization of trace formats, similar to OpenTelemetry for traditional observability. There'll be more sophisticated tools for automated trace analysis. Imagine AI agents that debug other AI agents. And evaluation is going to become increasingly automated, with benchmark suites for different types of agent tasks.
Any specific recommendations for teams just starting out?
Start small. Pick one critical agent workflow and instrument it thoroughly. Use that to develop your observability muscles. Set up automated alerts for anomalous behavior, like when an agent uses 10x more tokens than usual or calls the same tool repeatedly. And most importantly, make trace review part of your regular development cycle, not just something you do when things break.
This really changes how we think about testing, too, doesn't it?
Completely. Traditional testing assumes deterministic behavior. With agents, you're testing probability spaces. You need to run the same scenario multiple times and look at the distribution of behaviors. Some teams are doing behavioral coverage, ensuring their tests exercise different reasoning paths, not just different inputs.
What's your take on where all of this is heading?
I think we're witnessing the birth of a new engineering discipline. Just like we went from print statements to structured logging to distributed tracing in traditional software, we're going through a similar evolution with AI agents. The teams that figured this out early will have a massive advantage as agents become more prevalent.
So if I had to summarize the key takeaway for our listeners,
Agent observability isn't optional. It's the foundation of reliable AI systems. You can't improve what you can't see, and with agents, what you need to see is fundamentally different from traditional software. Start building that visibility now before your agents become too complex to understand.
And I think the most interesting part is that this isn't just about debugging problems. It's about understanding and improving how AI systems think and reason.
Exactly. We're not just building software anymore, we're building systems that can reason, and that requires us to reason about their reasoning. It's meta, it's challenging, and honestly, it's one of the most exciting developments in software engineering in years. Before we wrap up, let's catch up on this week's infrastructure news.
There's a fascinating new development in the AI security space that's causing quite a stir on Wall Street. Anthropic just unveiled Claude Code Security, and according to Bloomberg, cybersecurity stocks are taking a hit as investors react to this new player in the market.
That's interesting. It sounds like Anthropic is expanding beyond just conversational AI. What exactly does this tool do that's got traditional security companies worried?
Well, the details are still emerging. It appears to offer new capabilities in code security that could potentially disrupt the competitive landscape. We're seeing established players in the cybersecurity sector lose ground as investors reassess the market dynamics.
Speaking of security and infrastructure issues, there's a critical warning for anyone self-hosting applications with Spanish users. According to a Reddit post that's gaining traction, Spanish ISPs are blocking entire Cloudflare IP ranges.
And this isn't about malicious activity. It's collateral damage from anti-piracy measures. Legitimate sites hosted on those IP ranges are getting caught in the crossfire, leading to unexpected downtime for self-hosted applications with Spanish audiences.
That seems like a pretty heavy-handed approach. Are there any workarounds for affected users?
The community is discussing various solutions, but it highlights the risks of relying on shared infrastructure when regional regulations come into play.
Now, here's something that'll blow your mind. Someone on Hacker News is showcasing a way to run Llama 3.170B on a single RTX 3090. That's a massive model on consumer hardware.
The secret sauce is a high-efficiency C++ and CUDA inference engine that streams model layers through GPU memory. The really clever part? It can optionally bypass the CPU entirely using NVMe-to-GPU direct transfers. The project is called N-Transformer on GitHub.
That's incredible efficiency. This could really democratize access to large language models for developers who can't afford enterprise-grade hardware.
And finally, in a sign of the times, Bitcoin miner Mara Holdings is making a major pivot into AI infrastructure. Coindu reports they've acquired a 64% stake in Exaion, a French computing infrastructure operator, for $168 million.
It makes sense. Bitcoin miners have massive computing infrastructure and energy contracts. As crypto mining becomes less profitable, pivoting to AI compute could be a smart move.
Exaion is actually a subsidiary of EDF, so Mara is getting some serious infrastructure credentials with this acquisition. It's another example of how the lines between crypto and AI infrastructure are blurring.
That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.